Hello, Fruitport High School AP Chem students. Mr. Kovalak back at you again for our second lesson today if things are going as planned. And today I want to talk about how to go from percent composition into empirical formulas. Now, if you remember, percent composition is percent based on mass, and empirical formulas are a ratio of the atoms in a compound. Now, and more importantly is knowing the molecular formula, but that's got more steps, and so we'll get those in a later lesson. So let me take you back to here. You'll see in Google Classroom a copy of these notes I created. You won't find these anyplace else. And you'll see the full shebang, how to go from percent composition to empirical formula and eventually to molecular formula. But it's not an easy one-step process. So we have this roundabout four-step process that I created to make it foolproof. Okay? So let me tell you what will happen sometimes is that you might get a machine in the lab to discover an unknown substance, like a white powder at the crime lab, and they want to find out if that substance is a poison or an illegal drug, and they want to figure out the formulas. And so how do they go for percent composition of formulas? Well, they have computers that will do these steps, but in your lab, you're going to have to do that differently. Another possibility is you won't start with percent composition, but we'll actually start with grams because you actually measured things in the lab. Okay? And so, again, we're just going to take a look at this, do a couple sample problems, and we'll do the steps at a time, okay? So the first step is we're just going to copy the percentage into grams. That's really easy. Second is we're going to take grams and convert to moles. If you remember how to convert grams into moles, we'll use division and mm for molar mass. Now, these moles need to be in a mole ratio that has whole numbers, which sometimes you could just eyeball it and you can just jump right through steps 3 and 4. But sometimes you might need to do this step, which sounds confusing. Divide all mole by smallest mole. When you see an example, you know what that means. And then to go from a mole ratio has 1, that's the point of doing this step. You might not have all whole numbers, so to get to whole numbers, you might need to do some rounding or like doubling or tripling. Okay, so let's do a practice problem and see how it goes. Okay, so let's say you're given this situation. You have a compound that is found to be 25.9% nitrogen, and it's also found that the rest of it, 71.4%, is oxygen. And we want to know, what's the formula going to be? We know it's an N and an O, but how many N's and how many O's? We don't know. Okay, so step 1, take these percentages and convert them to grams. So we can kind of cheat with step 1 and say, well, you know what? If I weighed exactly 100 pounds and I was 24% body fat, I know I actually have exactly 24 pounds of fat on my body. And so we can do the same thing. Let's pretend we had 100 grams of this unknown substance. Well, we would know that 25.9 grams would be nitrogen and 74.1 grams would be oxygen. Okay. Step 1, complete. You just copy the numbers. Step 2, we have to take grams and convert into moles. And we do that for each separate line. So for step 2, I'll do that in maroon. I will take nitrogen and divide by 14, and oxygen I'll divide by 16. I hope you know where those numbers are coming from. Those numbers are coming from the mass of the atom on the periodic table. And those are not, don't worry about them being diatomic, okay? And I'll get 1.85 moles of nitrogen, and 74.1 divided by 16 gives me 4.63 moles of oxygen. Now, we cannot put 1.85 and 4.63 in the formula, right? We always use whole numbers in the formula. So our third step, second step done, our third step is to try to get that into a mole ratio. And sometimes people, they just kind of see it and they can go, but a lot of times we can't. So step 3 on our note sheet says this: take all the moles, in this case there's 2, divide by the smallest mole. So which is smaller, 1.8 or 4.6? So I'm going to take this and divide it by 1.85. I can do that in my head. I get 1. But I also take this and divide it by 1.85. And when I do this, I get 2.503. Okay. Now, it would be nice if this was exactly a 4, exactly a 2, or exactly a 7, because if I have whole numbers after step 3, what I can do is take those numbers and plug them in here. If a number is really close to a whole number, I can also round it. Let's say this came out to be 3.999. Well, that would have essentially been 4. And I could have stepped to step 4, where we take the mole ratio and get them to whole numbers. We can round if we're close, or we can double or triple or quadruple all the numbers. In this case here, we are going to want to double the numbers. I can just see it. If you need to do guess and check, you can. If I double 1, I get 2. And if I double 2.503, I essentially get a number that's really, really close to 5. This has been the whole point. We now have, for nitrogen, a 2. And for oxygen, a 5. Our final answer, N2O5. This is the empirical formula. Each step along the way is not completely challenging and hard, but you have to do so many little steps along the way that it can get a little bit challenging not to make a mistake someplace in the process. Okay? So, and again, this doesn't have to be doubled. If I ended up with like 0.33s or 0.66s, that's like thirds, I would triple. If I ended up with 0.25s or 0.75s, that's like a quarter of the way, so I might have to quadruple. But do notice that you have to double both sets of numbers. If this one's a whole number, but this one's not, you have to double both of them to get the answer here. Okay, so we'll do another one here, and this next one that I have has, in fact, 3 different numbers to follow along. All right, so we're looking for an empirical formula. It's C something, H something, O something. We don't know, but we're told that it's 64.3% carbon, 7.14% hydrogen, and 28.6% oxygen. And if you check up this, they should add up to equal a number really, really close to 100. If it's not exactly 100, that might be a rounding or a sig fig kind of issue going on. Okay, so I'm going to do all my carbon on this line here, all my hydrogen on the line, and all my oxygen. Remember, step 1 is just take those numbers and put a grams next to them instead of a percent. So I will now have these values. Okay. Step 2 is to divide by molar masses to get to moles. So carbon's molar mass is 12, hydrogen's molar mass is 1, and oxygen's molar mass is 16. So I can do that one in my head, so I like to do that one first. And then I'll take calculator here, 64.3 divided by 12. I got 5.36 moles of carbon. 28.6 divided by 16, 1.79 moles of oxygen. Our next step is to take each of these 3 moles and divide by the smallest mole. So I think 1.79 is the smallest. So I'll do this. Again, maybe I can see whole numbers here, but I can't. So I'm going to go ahead and do the steps. So I'll take 7, so I'll go in order. 5.36 divided by 1.79, and I get 2.99. Oh, that's good, because that's really close to a whole number. And 7.14 divided by 1.79 equals 3.98. Oh, and that's nice, as it's really close to a whole number too. And my last step, I want to get to whole numbers. I do not need to worry about doubling or tripling, because this is pretty much a 3. This is pretty much a 4. This one, of course, equals 1. This is my answer. C has a 3. H has a 4. Oxygen has a 1, but we know not to put the 1 in there. Okay? We're going to do this in lab with grams. You're going to do this in homework. I'll try to put there's other examples in the book. There's videos, and it will get more complicated the second half of the week, but I hope you enjoy.